Hello guys, okay, please begin. I guess so. Is my voice audible? Okay, I think it works. Is my screen visible? Okay. Let's start writing the code. Initially, we are going to start with problem of the day. I think I started with someone like this. No. Okay. One input and two efficiency. Okay. So, okay, guys, I think we can solve this question. Let's go with the no. This question is simply talking about we need to do some operations, some magical operations. Then let me take a grid. In each grid, what we have to do is we have to mark a diagonal and we have to make sure that every value above this diagonal should be a zero. Okay. The lead code question number 1536. Question number 1536. Okay, we have to make sure every value must be a zero. Okay. To make these all values zero, what we have to do is we have to initially get n, right? Uh, like size, column size. We have to select n minus one zero row, n minus two zero row, kind of say, and a row with n zeros or smaller. So I think if we select the values in n minus 1, n minus 2, n minus 3, we assume that we have to store these values in a vector list. If I had 4 zeros here, 3 zeros, 3 zeros, 2 zeros, yeah, we simply have to sort this, and make it available. We have to make sure that the above diagonal are zero, but in question they again ask about, yeah, minimum number of operations. If if we take three operations to arrange the first row and four operations to arrange the second row, and again two operations to arrange the third row, we don't need to arrange the last row, right? So last row will be eligible for the operation count, and the second row, first row, and the n minus one row are eligible to calculate the minimum operation. So to extract the minimum operations, what we are gonna do is, I'm thinking, initially I have to extract the number of zeros that I get, like from contiguous zeros signal from loss. First, I have to tell, is it possible to maintain? If I had four, initially I need to have four. Assume the grid is 5 cross 5. I have four, four, one, three, two, nine, one, one, two, four, three, five, two, one, zero. These are the requirements. Four was satisfied. Next, this one was satisfied. Next, this one not satisfied. So what we have to do is we have to simply swap the next greater element than this value. Instead, minimum operation is 2. How can I find this? How can I find this? Is it about sorting? If I sort these values, they are absolutely fine to do that, but I think it's not necessary to do that. If we found this, we have two, one, two, here a two, here a two, to swap here. Yeah, you have to check the next moment. Like we have one, three, two. We have to pick three here. Yeah, next the greatest element index. So simply sorting. But how can I again redefine, like these all values will be fixed to one place, right? Um, so suppose I have to arrange the smallest one first. If we arrange smallest one, like I move one to here, then two will be placed here. Eight, four, three, four, 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 one, three, two. Mean one here will be enough. Is arranging the smallest value necessary? Necessary? No, we have to arrange by greatest value, like maximum value. If the value is sitting here, ignore them. And if I have some value like 5 here, I have 3 here. and 2 here. Here one operation is enough. But what I'm trying to do is I am extracting the maximum value. No, what I have to do is I have to do binary search here and search for value just greater than this value. 5, okay, just greater than this value and extract that value to here. If I do binary search here and move that value to here, then what is the operation for the next one? If I move that value to here, then the indexes will be moved a bit, right? Here some complexity. Let me take the time complexity of the question. Oh man, simple 200. We can do group force. We can do brute force here. 200 into 200 into 200. We can do brute force. 10 for 6. Even if we loop to do this, we are good to go. Okay. You understand my point? We are arranging in a way that the first greater element and people, right? If I pick first greater element, did I get any problem? I have one here. What I need is two. What I need is two. If I took too much big, what I required is three. The next one is definitely small one. I just want the next. I just want the next maximum. Yeah, I just want the next maximum. I don't care about what value it is. Because it continuous decrement. If we have two somewhere, it will be useful for the next value, right? So no care about the value. Just stick to this maximum. So I take this phone, take that value, bring that value into here. Yeah, it's simple. Remote implementation, I think the solve this, people can solve this in a pretty easier way. I know that. Well, sharing the coding area, let's test out our theory about solving this problem. Is this problem, I will rate this problem as like out of 5, I will give 3, not because it's a medium, because it's some low graded code, like low quality code. If any by chance any of the constraints go a bit higher, like 1,000, then it's something to be problem. And initially doing, we are taking n. Now my next move is extract the number of consecutive zeros at the end. So the form is n of n equal 0. So you guys can drop some messages or comments. I will check that. Again, let's continue again. We have to take count, right? E equal to 0 or n to j equals to n minus 1, j greater than or equal to 0, u of 5, j equals to 0, c plus plus. I forgot to implement it. Sorry, declare this. Minus, yeah, that's enough. Allow 5 for 50. Okay, now we have to think about sorting. Next greatest element index I mean, okay, to get next greatest element index, no, okay, first for int I equals to 0, I less than n, I plus plus, int current required equals to n minus 1, comma, OP equals to 0. If L of 5 greater than or equal to current required, just continue. L of 5 less than or equal. Whatever happens, current required will be trigger. What I need here is the first value which is greater than or equal to current required. The first, to get the first value greater than or equal to current required, I am using another loop here. For in k, sorry, j equals to 0, so no, j equals to I plus 1, j less than n, j plus plus, and maintaining flag if it's not possible, it will return, yeah, if, if int id equals to minus 1, if L of 5 greater than or equal to current required, id equals to j, rate. If I found minus 1 id, if id equals to minus 1, we just make flag equals to 0 and break it, or else we have to swap the value of the here. Here equals to L of id for int j equals to id, j greater than I, j minus minus, L of 5 equals to L of I minus 1. Swapped here, operation plus plus, and L of 5 equals to Vn. Now here again operation plus plus. That's it. This is what I think that would do. Return. Okay. Hmm. For loop. Done with now. So, runtime error. There would be the error, not equal to. Only less than. The new system. Wait. Initially expect how to extract this ATM, your IP. What are the values storing in that L? 0, 1, 2. What are the code is 1. A swap here, 1, 2. Only 2 here. Current record is 2 here. Wait. minus one, why? Okay, here the condition I have to check allowed here, right? Then here too, allowed here. How down by here, and not five operations. I have to print out number of operations to take at every step. Mm-hmm. Whether remember the station, whether now let's take how many operations. The first operation is three, wait one. A tracking only takes processing unit. Three operations, tracking small 100% of code. So I think it will work if you really yeah, 100% of when with the same taking point, what that, needle, zero, you're taking change, doing the swaps. It's all the same again. Okay. Communicate. Let's bring with it and be securely someone has viewed my level, basically lower. Somehow zero drop trail. Zero drop trail. Draw. Okay. That's live good. Only guys, most wanted to explore in a just easy tempo. Random thing. How many questions can I solve here? 3557. I think I solved this contest. I gave it live. Came back to five. How many questions do you guys think that I can solve? A 30 seconds a drink break and we will start. And then for readers, we can release 5 minutes before this content and where we learn subject. One more variable learn subject. We will learn subject. Given means we learn for those that people come up and concept. We are creating physics summary of time and and if I take 20n as a size, n as size, okay, I'm taking a sum variable, iterating through the value, s plus equal to a of 5, f of 5 equals to 0, reverse, and again, don't ask me how I did this. It's a pre-planned technique you guys can learn. If you request, I will stay reading in it. So, so this is this the type 1 and type 2 coordinates? Is my voice that dumb? Can I change the voice? Hello, mic testing. Any guys for any slide? Hello, mic testing. My voice burning in this below. Maybe my earphones worried. Maybe my earphones had a problem. Let me take a voice again in another.
Is my voice audible now clearly? I think it is. I think it is now coming through this mic. In previous up until now, my voice is from my earphones mic. We are doing like A size here. Okay, now let's solve this problem. You are given an integer array of size norms and positive integer k. Return the sum of maximum and minimum elements of all subsequences nums with utmost k nums. I can brute force this, but my aim is to solve the Q4 also. What I have to do is minimum and maximum minimum sum of at most k subsequences. Is k subsequences. What I can do? Hmm. I won't talk until someone comment on this line. I won't. రేపు రేపు కాదు ఎల్లుండి రమ్మన్నారు. రేపు సెలవు అంట. రేపన్న నాతో సెలవు. Hello, is someone watching? Hello, did someone watch the channel? I will be interactive from this time. Okay, we are now solving the problem here. Okay, we have to take every element, like every element, in an array and we have to sort them out. The current value will be maximum for the current value will be maximum for I plus 1 values, I plus 1 star E of I, and it is minimum for n minus I minus 1 values. So we have to use some modulus thing. Yeah. We are doing a modulus operation here. If someone is watching a stream, just use the chart option here. Sum modulus that value and return the sum. Okay, I get 18 here. Every value is like repeating n plus 1 times here. So I am using s mod I. So it will give me the number of values, number of time it repeats. Will this work now? Yeah, it works. 24, 44, 12. 24, 44, not n plus 1 times. We have to use if the k value equals to 1. If k equals to 1, then it depends on k. If it depends on k, I solved it for k equals to 2. It completely depends on k, but I solved it for k equals to 2. Now n mod I. Let me do the flux again. K. I have to take a k values from here. Can I take a k values from here? I need to check. If yes, like k minus 1 values, how many possible k minus 1 values I can take from here? How many possible k values I can take from here? This is the value at kth position. If it is at last, like I have k minus 1, C, I have k minus 1 positions. and I have some n values. I have to take k minus 1 positions. How many ways? Like I can take uh, k minus 1 positions, right? It must be greater than k minus 1. The index should be. Okay. Now I get it. What I will do is at here n into n minus 1 into n minus 2 up to n minus k divided by k, isn't it? I want the product of like n factorial, but not completely. I want the mid range, like up to here, n into n minus 1 into. So I will use a prefix product to pre-computation. I will use prefix thing for recomputation, for pre-computation. Okay, let's see what I can do. Okay, sorted and some, yeah, everything is fine. What I have to do inside was not fine. I will make it fine by doing it fine. Vector int prefix sum of n comma 0. What I want is I want k minus 1 factorial every time. Does that what I want? No, I want n, n minus 1, n minus 2, n minus 3 up to how many values that I have. Okay. Initially, f of 0 holds n. Now, for int I equals to 1, I less than n, I plus plus, f of 5 equals to f of 5 minus 1, star n minus I mod prefix product. Yeah, that's it. Now we have to start with I equals to k, right? No, I equals to 0. How many values in the left? Int left values are I minus, means how many values that it can be a maximum. It can be maximum for current value, right? I plus 1. How many values in the right? N minus I. If L uh, if L greater than or equals to K, then number of ways to put fill those elements. Not a permutation, right? Not a permutation. It's a sequence. So again a problem. What was the fourth problem again? subarrays it is. It is for subsequences. Why subsequences are that much? Okay. We can do this by extracting minimum of all 70 sizes subsequences and maximum of all 70 size subsequence. Hmm. Yeah, but where I'm stuck here is like I have some here I have my value and here have some values. How many ways, how many sequences that are formed here in k minus 1 positions? Like assuming it is an array of size n and I want k sequences. How many ways? I have to fill DP first. Yeah, it is just sum of n minus k minus k, just as it assumed. Yeah, I need that. Not this factorial.